So this is the answer key for the Unit 4 test review. And we're going to start off by talking about how many solutions we have in a system. And starting with the first one, let me spin a little bit more. So it says, how many solutions do the system of equations below have? So the first one is a set of parallel lines. And when you have a set of parallel lines that never cross, that would be no solution. And I am going to also, just to write it again because there's a question about it later, I'll also write down if it's consistent versus inconsistent and dependent versus independent. So when it's no solution, this one has to be inconsistent. There's no other one that means inconsistent. Again, remember, inconsistent is when you have no solution at all, like there's no intersection at all anywhere between the two lines. All right, the next one, it looks like it's just one line at first, but if you look at it, there's like two sets of arrows in there to show you that it definitely is one line sitting right on top of the other line. And so when that happens, that would be an infinitely many solutions scenario. And so that would be, if it's infinitely many solutions, we'll then write down how to classify it also. But in terms of how many solutions, there's an infinite number or infinitely many solutions. So now in order to write down whether it's consistent, inconsistent, again, the question didn't ask that, but it helps to identify that now so that it helps again, just so that the next few problems we do the same thing. So inconsistent, remember, was when they don't intersect. So this has to be consistent because they intersect all the time. And specifically, it can either be dependent or independent, and infinitely many is always dependent. So questions that you see about this, you can definitely check it up in your notes or on this review packet when you're seeing that question on the test. There will be a few like this. And so again, anytime it's infinitely many, it's always consistent and dependent. The last one is one solution because they intersect one time. And then we want to say that this is consistent. And then you want to say if it's independent or dependent. Independent, like that. Okay, so independent always when there's one solution. Otherwise, if it's infinitely many, then it's dependent. Remember, for inconsistent, it can't be either dependent or independent. So it's only one or the other. All right, moving on to the next part. And again, we're going to still classify. But first, these were graphs. Now we're moving on to equations. And specifically, these equations are in standard form. So if they're in standard form, you don't have to solve them. If it was in y equals mx plus b form, it would be easier maybe to see sometimes how the two are related. But what I do see here is hopefully that you notice that the first equation has a 3, a 4, and a 12, and the x's and the y's are stacked like this with the numbers stacked as well. And if you notice how the next row changes, it's a 6, an 8, and a 24. So each of them have been doubled. The whole first row was doubled to become the second row, or let's see if it's actually going to become that. So if I take all of this equation, the first one, and I multiply it by 2, I get 6x minus 8y equals 24, and these two equations are then the same. If that happens where you have two of the same equation, at first glance you might not have realized that, but because they are the same, that would be an example of infinitely many solutions. So first of all, write down that it would have infinitely many solutions, and then just I'll reclassify it like we did above, that means consistent, and dependent. Remember, dependent is infinite, independent is one solution. So anytime you see two equations where they look similar in terms of like, let's try to multiply everything, or you could take the bottom equation and divide it all by 2, that would be the same thing as seeing that it looks the same as the first one. So like on the second one, the problem here is the x's and the y's are not in the same order. If you see, they're not stacked. So I'm going to first rewrite so that they are stacked. So I'm going to rewrite the top one as it is, because I like seeing x first. We're kind of used to that. And then I'll write the second one with negative 16x and 12y and a negative 42. So this time, if you kind of compare the two equations, still it does have a double, like the first row does get doubled, sort of, not exactly by 2, but by -2. If I multiply both these numbers by -2, it'll be that bottom row. Or if I divide the bottom equation by 2, I would get it to look like the top row. But here's what I'm going to do. I'm going to first multiply this by -2. And the reason I'm doing it by -2, actually I'm going to do this in another color. So you can see that this is the work I took to get my new equation. So it would become a -16x, a +12y, and a -40. Now this time when I'm looking at my two equations, the left-hand side will all cancel out. Well, is all the same as the left, is all the same. But the right-hand side is not, because one of them is a -42 and one of them is a -40. This would not be infinitely many solutions. These would be no solution. So if you see everything else is the same except for the two numbers here, the final answer here becomes no solution. Okay, and then if it's no solution, remember that means inconsistent. That's the only way we need to classify it, because independent and dependent are only classified when it's consistent. All right, let's keep going. Tell whether the solution, or for 3, -10 is a solution of this. So all we have to do is just substitute in our x and our y. So it would be -10 is less than 2 times 3 plus 3. 2 times 3 is 6, and 6 plus 3 is 9. So you're asking yourself, is -10, I sometimes put a little question mark here, is it less than 9? And that definitely is a true statement, because a negative number is always less than a positive number. So this one would be yes. It says, tell whether it's a solution. Yes, it's a solution. But for the next one, let's see what happens. So we're going to, again, plug them in for x and y. Make sure you don't switch the order. So 2 is what we plug in for y. And we're asking ourselves, is it greater than -5? Because there was a negative right in front of that x. And then I plugged in that 5 plus 18. -5 plus 18 is 13. So we're saying here that is 2 greater than 13? And we know that's not true. 2 can never be bigger than, a number like 13. So that's why this answer would just be no. It's not a solution for that inequality. So this means, like, if I was to graph these inequalities and shade them, the point would not be in the shaded region. And we'll practice some of that coming up on the next examples, or next few examples. All right, the next one, number 4, is to solve the system by using substitution, and our final answer has to be expressed as an ordered pair, x, y. So the first thing you're going to do is, when you see your two equations, you want to look for one of the equations to be in the form of x equals or y equals. Well, neither of them are, but the second equation here has no number in front of the y. So you're looking for which one of them does not have any kind of coefficient, like these have a 3, 7, and 4. We don't want any of those. We want to get this y alone. So I'm going to subtract 4x. So I have y is equal to, and I'll put this in terms of like mx plus b, but you could write it as -11 minus 4x. It doesn't really matter. All right, so that's gone. And this is my new equation that I'm working with from this original second one, and I'm using it with the original first one. Okay, so I have two equations I'm working with. I want to take this whole y equals, this part here, and I'll use a color here to show. We're going to take this -4x minus 11 part, and we're going to plug it in for the first equation's y. So let's go ahead and see what this looks like. We start with 3x plus 7 times -4x minus 11, and it equals -2. So we're going to keep solving until we find x, and then after we find x, we'll find y. So first of all, to keep solving here, 3x minus 28x minus 77 is equal to -2. Then we have combine your x's. So we have 3x and a -28x would be a -25x. And then we want to move the 77 over to the other side by adding it. So this is negative 25x is equal to 75, positive 75. And then when I divide by negative 25, we get x is 3, or negative 3. Okay, and then once I got part of my answer, I have my x now, I need to find my y by taking my answer, this negative 3, and substituting it back in here to find my y. So we have y equals negative 4 times negative 3 minus 11. This would be positive 12 minus 11, which is 1. Y equals 1. So we have our x, we have our y. We would write our final answer as an ordered pair. X goes first, then y. That would be my answer. So on the quiz or on the test in Michigan Virtual, you're going to write your answer just like this as an ordered pair with parentheses, comma in between them. Now we can check our work though to make sure we did that correctly. It is easiest on a calculator. If you have a graphing calculator or if you want to use like decimals, that's up to you. So on a calculator here, we're going to substitute in negative 3 in for x and 1 in for y. So if I do that with the left-hand side here of the first equation, we have 3 times negative 3 plus 7 times 1. When I hit enter, I should get negative 2. And I do. So I did that right for the first one. The second one is y first. So 1 plus 4 times negative 3. That's 4x equals, when I hit enter, I should get negative 11. And I do. So both those, it works. The equation, the answer I got works in both equations. So I know I did that right. All right, let's keep going. The next equation, we're going to use elimination. Now, elimination is different from substitution in that they both equations should be in standard form, which looking like as they are right now. So, and everything's kind of lined up, which is easy to see. You're looking for opposites. So if I look at 3x and 3x here, they're the same. I want opposites. So you actually have to make one of them into a negative 3x because that's how they would cancel out, because they would become opposites. So I'm going to multiply by a negative, or negative 1, to that whole bottom equation. Now, you could have done it to the top equation. It makes no difference which one you want to multiply to. I just decided I wanted to work on the bottom one. But again, up to you. So we have negative 3x, a positive 4y, and a negative 14. The top equation, I'm just going to rewrite it exactly the same. And now we want to add straight down. So the 3x's are gone. X's are gone. The y and the 4y becomes 5y. And the 4 and the negative 14 would become a negative 10. And then divide by 5, and y equals negative 2. So I found my y. We're halfway there. And once I have my y, I go back into one of these two equations. I would recommend going into the first equation only because the y doesn't have any number attached to it, so it might be a little bit easier. So we have 3x plus negative 2. You could have just done minus 2. That's fine too. Equals 4. And so you're solving for x. So we're adding 2. 3x equals 6, and then dividing by 3. And x equals 2. So we found our x, we found our y. I'm going to write it as an ordered pair. And now we have to check it. And again, it's easiest to check it on a calculator. It's not required to check it, but you should definitely know if you're doing it right, on your test. So before you leave the test, you know that you've done it right. So let me go ahead and plug in a 2 in for x. I'm using that first equation, plugging in 3 times 2 plus a negative 2 for y. When I hit enter, I should get 4, and I do, so that part's good. Do the same thing for the original equation for the second one. So 3 times 2, that's my x, minus 4 times negative 2, and when I hit enter, I should get 14, and I do. That part is 14 right there. So that's how you know you did them right. All right, so if you have questions on these as you're doing it, please consider coming in the afternoon for some extra help. I can go over any of these at that time. Let's keep going. So number 6 on the next page, it now says you can pick whatever method you like. So starting with the first one, it's kind of everything in one side. And then the second one is in y equals form. So again, when I see y equals, I recommend using substitution. So I would not do elimination unless they're both in standard form. And I don't want to move stuff around now. So I'm going to take this 3x minus 6 and plug it in for this y. So we have 3x minus, now here's what's important. You have to put the 3x minus 6 that you're plugging in for y in parentheses. If you don't do that, you will get the wrong answer. Then there's a minus 6, and then an equals 0. So we are solving this for x. Let's see what we get. So first thing you have to do is distribute, actually let me bring the 3x down first. Then we have to distribute this negative, like switch both those signs. You get a negative 3x and a positive 6. Then we still have this minus 6 here. And now we're dealing with that whole left side. So if you look at it though, 3x minus 3x, there's nothing there. Those are gone, right? 3x minus 3x means x is 0, or there's not x is 0, but there is no x, 0x. Same with the 6 and the negative 6. Those are opposites. Those are gone too. So technically, I have nothing left on the left side. It's just 0, and it's equaling the same 0 on the right side. And when two things equal each other, like 0 is always equal to 0, this is a true statement. And when that happens, we have to write the words infinitely many solutions. So when you see this question on the test, I'm sure it's going to be on there, when you get to a point where one side is equaling the other side, that's always a true statement. You can even say it's true. You want to find the answer because it's going to be multiple choice most likely. You want to select the choice that says infinitely many solutions. All right, here's another one. Another one that's kind of set up for substitution one more time. So it's up to you if you want to switch it around, but it's easiest probably just to substitute that in for the second equation's y. So we have x plus, and then I'm plugging in my negative x plus 8 equals 4. Now x and negative x cancel again. So now I have 8 is equal to 4. Now that's not true. 8 cannot equal 4. So since that does not hold true, it's a false statement, we now need to write down our answer, which is no solution. There's no possible solution here because x got eliminated. That means x can't be anything we know. It can't be a solution. And specifically, you can see why, because those two numbers are not the same, whereas they were here. That's the main difference. You'll probably at least get one of these, if not both. So make sure you look out for that. And there's not really a way to check these because there's no numbers to plug in. But you can check them if you want to put them into y equals form and graph them. That's one way to check them. Here's one last one of solving using any method. This time I would definitely recommend using elimination, right? Because they're in standard form. The main idea here is look for opposites. Now 3x and negative 2x are not opposites, they're different numbers, but 4y and 4y are the same. I can do this by making the second equation switch to a negative 4y, or I could do it to the first one. I'm going to go ahead and just do the bottom one. So I'm going to multiply it by a negative or a negative 1. Let's see what we get here. So we have a negative 2x. I'm sorry, it's not going to be negative anymore. We have a positive, I'll actually just write it right here. A positive 2x, a negative 4y, and a positive 22. The top equation, though, I'm going to go ahead and just bring it straight down because it stays the same. And now we can solve it by adding straight down. 2x plus 3x is 5x. Negative 4y and a positive 4y cancel out. No more y's. And then a 22 and a negative 72 is 50, or negative 50. And then when you divide by 5, we get negative 10. So we got our x value. Now we need to find the y, and we're going to do that just by plugging back into either equation. I'll just go into the first one. So 3 times negative 10, because that was x, plus 4y is equal to negative 72. That would be negative 30. You want to add 30. So you get 4y is equal to negative 42. Divide by 4. and you get negative 10.5. Oh, I'm sorry, you know what? Oh, no, that's good. Okay, so once we get our answer, we're gonna go ahead and write it as an ordered pair. I wasn't sure if this was the right answer, so I'm gonna double check. There's a possibility I did do something wrong. We'll find it. So let's go ahead and check our answer because I didn't know that that was gonna be a decimal. But let's see, 3 times negative 10 plus 4 times negative 10.5 should equal negative 72. It does. That part is good. Then do the same thing for the second equation. Negative 2 times negative 10 and plus 4 times negative 10.5. That should equal negative 22, like the second equation. See if it does. It does. So we know we did that right. So even though I thought maybe I did something wrong because I got a decimal, that's okay. It's okay to get decimals sometimes, and then you know for sure you did it right because we checked our answer. All right, so now we're on to story problems. And the main idea here is we're still solving them, but you still have to just write the equation first. And it helps to define your variables, use highlighters. I can use a highlighter to write down the important stuff. So Ms. Doctor decided to purchase M&M bags and Hershey's bars for all of our students. Each M&M bag costs $3. Okay, that's important. While each Hershey bar costs $2. So those are the costs for each one. She ended up spending $16 in total on her purchases, and there were 6 items in total. So 6 is a total. All right, we are now going to try to write an equation, 2 equations, and then solve them. It says how many M&M bags and Hershey bars did she end up buying? So first thing you're going to do is figure out what are you trying to find. That's your unknown. So number of M&M bags and the number of Hershey's bars. All right, and now we can write our 2 equations, but always try to define it first because it makes a little more sense as you're trying to write your equations. So one of the equations is going to have dollar signs attached to it. So $3 times X, because that's what M&M bags, how many there were, plus 2Y is going to equal $16. So if you notice, everything in this equation had dollar signs. I'm going to go ahead and write a little dollar sign there. The second equation should deal with the total number of items. And so since these represents numbers, I'm going to just use X plus Y. Altogether, the number of M&M bags and Hershey's bars is 6. That's how many I bought. Okay, so then we want to solve this. And so that you can do it either elimination or substitution. Is entirely up to you which way. I'm going to go ahead and do elimination because when I see them already in standard form, that's kind of where my mind goes. So -3 or -2 is what I can multiply this whole second row by because that's how I want to cancel it out with one of these 3 or the 2. It doesn't matter which one you want to cancel out. So we'll just go ahead and do the -3. So my new equation is -3x minus 3y is equal to -18. And the top equation stays the same. 3x plus 2y is equal to 16. But you want to add straight down. So x's are gone. We have a negative y because -3 and +2. And this gives me a -2. 16 minus 18. And then divide by -1 and you find out that y is 2. So far I found out that since y represents the number of Hershey's bars, I bought 2 Hershey's bars. And remember, since x and y together are 6, you don't have to even solve this really. You could probably do this in your head because if there's 2 Hershey's bars and in total there's 6, you just want to subtract 6 from 2 or 2 from 6. But if you do want to show it work, you would do x plus 2 is equal to 6, subtract 2, and x would be 4. So you found your x, you found your y. We could write our answer in words because saying how many of each bag did she get? She got 4, or I did, 4 bags of M&Ms and 2 Hershey's bars. All right, that's the final answer. Okay, let's move on to one more story problem, and then we're going to finish up with one more solution and get on to graphing. So it says Movies R Us has two video rentals plans. The video rental plan charges $3.25 for a video rental, no membership fee. And so it's like each time you rent, depending on how many rentals you get, that's going to change. And then this preferred video rental plan has an $8.75 annual membership fee that you pay one time every year, and then charges $2 for every rental. So we're going to try to write equations for what happens in a year. So here's the first one. The regular plan charges $3.25 for each video, but no membership fee. The preferred plan, actually I'm going to do this in another color. So the preferred video rental plan has an $8.75 annual membership fee and charges $2 for each video. So by using two different colors of the highlighter, we know we can use that to write my two equations. So my first equation will be the regular plan. Actually, before I do that, let me identify my variables, because I'm trying to find how many video rentals will I need to get to cost this when the cost will be the same. So X is the number of video rentals, and whereas Y is the total cost, how much you spend using each plan. So here's my regular, here's my preferred, and then we'll solve it. So my regular, that's the pink highlighter, would just be y equals 3.25x. Think of y equals mx plus b, where b is 0 because there's no membership fee. The preferred plan, though, would be y equals 2x, because you're paying $2 for every video rental, but then you're going to add the annual fee that you have to pay, which is $8.75. These are the two equations. Now, when you see y equals and y equals like this, the easiest way to solve is by setting them equal to one another. So 3.25x is equal to 2x plus 8.75. So to solve this, we're going to subtract 2x. All right, and we get 1.25x is equal to 8.75. Divide by 1.25, and x will be 7. Now the question didn't say what's x, what's y, and like explain both answers. We just need to figure out how many video rentals will the cost be the same. And so that's why I set them equal to each other when we solved, because we're trying to see when do they equal each other? When is the cost the same? And that's after 7 video rentals. So at 7 video rentals, the cost will be the same. And that's it. If it goes on to say, well, what is the cost, then you would find y. But since it didn't, we don't have to do that. All right, let's finish up this page with this one, and then we have some graphing. So number 10 says, tell whether this is a solution. Similar to what we did on the last page, number, I think it was like 2 or 3. But here we're going to check both equations. So 8 is greater than or equal to 2 times 4. And this is 8 is greater than or equal to 8. That's true because of this little equal to sign. 8 can be equal to 8, and that's a true statement. Now, of course, 8 is not greater than 8, but that doesn't matter as long as one of these hold true, because this is called greater than or equal to. That works, but it has to work for both in order for it to be a solution. So let's see if it works for the second one. This is 8 is less than 4 plus 3. That would be 8 is less than 7. No, 8 is not less than 7. It is greater than 7. So that's why, since one of these two don't work, the answer is no. So it can only work if both, if the solution or if the answer ordered pair works on both inequalities. If it doesn't, then no, it's not technically in that common shaded region, which we'll do on the next page. So let's go ahead and move on to that last page so we can do 3 of these graphs, work with 3 graphs, and then we'll be all set. So identify the inequality that represents the graph below. This is a dashed line. It's shaded above. I'm going to write those things down. Dashed and above. So that's the first thing I usually do when I see a graph to help me decide the inequality. So if it's dashed, I know it's either less than or greater than, but because I'm shading above the line, this is all above it, it's going to be a greater than. So far I know that the inequality is greater than. I know that when I write an equation, I start with y, like kind of like y equals mx plus b, but I know it's a greater than symbol. Now I need to figure out what's my m and what's my b. So I look for my y-intercept. It's sitting down here at -2. So that's my b. Think of y equals mx plus b. My y-intercept is 0, -2. And then find a point on the graph so that we can graph this out. It looks like it is at each point here. So it's going up one, right one, up one, right one, and so on. Since it's going up one and right one, the slope is 1. And so my equation would be x, or you can put a 1 in front of the x if you want to, and then -2. Or my inequality would be that. Just y is greater than x minus 2, or 1x minus 2. But it's a multiple choice test, obviously, so you're going to just select the correct answer that probably won't have a 1 in front of that x. All right, on to the next one. We're going to graph this now. It's graphing a linear inequality. Instead of this one, we went kind of backwards and we saw the graph. We wrote the inequality. Now to graph the linear inequality, it's not in y equals mx plus b form. So that's our first step. Get it to that form. Add 4x on both sides. So we get 2y is greater than 4x plus 6. Divide by 2 everywhere so that we get y is greater than 2x plus 3. This is what we're graphing. Okay, so 3 is the y-intercept, 2 is the slope, right? M is, you could write it as 2 over 1 if you want to. Y-intercept is at 0, 3. We're going to graph a bunch of points, and then we will connect it with a dashed line. Because it's a greater than symbol, it doesn't have an equal to line. And I'm going to shade above it because it's a greater than. All right, so let's go ahead and start at 3. 1, 2, 3. And then you're going up 2, right 1, up 2, right 1, and so on. You can also go down 2 and left 1. All right, and then we are drawing dashed line. It helps to have like a straight edge here, but don't connect a straight line through it. Just put dashes like this. All right, and arrows because the line goes on forever. And now we have to just shade it in whatever direction. And so since it's greater than, and like I said, I shade above the line. So above is all of this here. Okay, and that's it. Now, of course, you're not going to do a physical graph. You're going to look for the correct answer as a multiple choice option. But just look out for dashed, look out for shading whichever way, and then the correct slope and y-intercept. All right, we're going to finish up with this last one. It's a system this time, so we have 2 of them. We're going to graph both and then look for where they have a common shading. So I'll use 2 colors here with the graph. The first one, I'll do it in this color, and I know it's dashed, and I'm going to shade below. And I start at 5 for my y-intercept, and my slope is -2. So 0, 5, slope is -2 over 1. So I can go down 2 and right 1, down 2, right 1. Keep doing that for a few points until I get most of my line drawn, and then use a straight edge to draw out a dashed line. All right. The second one, actually before I get to the second one, I'm going to go ahead and shade this first because it's below. And again, if it helps, you can kind of turn the paper the same way that the slope doesn't change, right? This is a negative slope right now, so don't change the slope to be positive. But if I turn my paper a little bit, it's easier to see above and below. So I'm going to shade all this below. All right, and now we are ready to graph the other line. So the other line starts at -3 for the y-intercept. This one is going to be a solid line, and it's shaded above this time. Starts at 0, -3. Slope is 3 over 1, or 3, but I can do up 3, right 1. So here's -3, down 3, up 3, right 1, up 3, right 1, The two lines do not need to intersect at right at a point because they're not looking for that solution, but this line should be solid and we'll figure out how to shade it above. So here is my line, and again, it's a solid line. That means no dashes. And now to shade it, we're shading above. So again, if you need to rotate your paper, you can, but make sure you keep the slope positive. It's still positive here. You don't want to rotate this way and now the slope is negative. You want to just, if you need to kind of make it a less steep line, looking at it like this might be easier to see that all of this is above. Okay, now when I go to find my final answer, especially for the Michigan Virtual, it's going to be a little bit darker shaded in the final area that there's two colors. So I'm going to make my area right here a little bit darker. So you use both lines as a boundary, so you don't cross the green part, you don't cross this pink part, and then that's how I know that this area here on the left is my final answer. And so we would look for that for your multiple choice answers. All right, and that's pretty much it. If you do have questions, again, please make sure you're coming for the extra help in the afternoons on Tuesday or Friday, or let me know over email if a better time works better.